Okay, let's take a look at, sorry, I need a drink of coffee. Let's take a look at section 11.7. It's actually the last section, so we are almost done, right? Looks like I did not share the screen with you, so you are not looking at what I am. Okay, that's better. Okay, so we're looking at section 11.7 in our book, right? Where 11.7 actually just shows us all the formulas at once, and we have to decide which formula we're using. So you'll want to click on the what formula to use sheet because it has all the formulas, right? So we have the simple interest formula, when to use it, right? The lump sum, future value, when to use it, right? We've got the present value of a compound interest, when to use it, and ordinary annuity, present value of an annuity, sinking fund, and amortization, and when to use these. And today I'll use the book's version of these formulas just to be consistent with this paper, right? And practice this form. So print this paper out, right? Have it available to you, take it to the exam, all that kind of stuff, right? Because these aren't worth memorizing, nor would I be able to myself, right? Like I know the first couple off the top of my head, and otherwise I need the paper too, right? So definitely use that paper as you're going through the homework problems. And let's take a look at what we have. So in number 2, we are asked to find the value of $1,000 certificate in 3.5 years if the interest rate is 2% compounded monthly, right? So what we have is we have a p-value, not a p-value if you're in stats, but we have p, right? The price of the certificate. We have t in years. We have a rate of 2%, right? And they're asking us to find the future value, right? So future value is our formula choice. So A equals P times 1 plus R over N. And we chose this formula because we have a compounding monthly, right? So, sorry, this book gets an N. Oops, that's not what I meant to do. Is there no eraser function on this one? Let's see. Okay, so we have N equals 12. For our exponent, we'll also need N times T, right? N times T is 42. And then we just plug and chug, right? We have 1,000 times 1 plus 0.02 divided by 12 raised to the exponent of 42. When I put this in the calculator, I get $1,072.45. A 6-year term insurance policy has an annual premium of $200 At the end of 6 years, all payments and interests are refunded. What lump sum deposit is necessary to equal the amount if you assume an interest rate of 2.5% compounded annually? So here we are looking for the present value of an annuity. So we're going to, let's see, we have an M. This time we have a regular payment and we have a T of 6 years. We're told that it's annually, so we have a 1. We also will need an NT. We haven't looked at the formula yet though, right? For present amount of an annuity, we have P equals M times 1 minus 1 plus R over N to the negative NT exponent. So that's why we need that. And then we have R over N in our denominator, right? Here we have a rate of 0.025 in decimal form. And then we plug and chug, right? So we have 200 times 1 minus 1 plus 0.025 divide by 1, right? So we don't really need that, but that's okay. To the negative 6, and then we divide by 0.025, which itself is divided by 1. Again, kind of an unnecessary step. When I put this through the calculator, I'll put in a cleaner version, right? 1 minus 1.025 to the negative 6 divided by 0.025. When I put this into the calculator, I get the result in dollars of 1101.63. Okay. Number 3. Oh, it's 3 in what we're doing, but it's number 4. What annual deposit is necessary? So they're asking us, they give us a couple of things right there. One, they tell us N equals 1 annual deposit. They're also saying we don't know what you're depositing, right? So they want to know M. To have a necessary future amount of 10,000 in 5 years, if all of the money is deposited at a rate of 1.5% interest compounded annually, right? So again, we will look for things like NT. NT is just 5, right? Because T is 5. We also do things like R over N, always in these problems. R over N when divided by 1 is just R. So we'll just use the 0.015. And then also note to self that 1 plus R over N is 1.015, right? When we divide by 1, then we get these simpler terms. So I'm just going to use the simpler terms when we fill out the formula, but what formula are we going to use, right? So they're asking us how much we need to deposit. Hold on. I have the formulas over here next to me in the book. So I was using the book for these formulas. And mostly I was looking in the book at page 555. That's like ways to figure out which formula to use. And then the formulas are on page 556. But you get that printout, and I really like the printout better than the book, actually. But since I'm just looking at the tablet and the book, then we'll use that. So here, in terms of the things we have and the things that we need, right? They're asking us for what is this monthly payment? We only have two options. That's the sinking fund and amortization. And in the sinking fund, they have A, right? We're given A. So ours is the sinking fund. So we're going to use the formula M equals A. Oops. Sorry, I'm using their formula this time. So it's the same as the one I was doing on the other videos. It's just this one is cleaned up to be a fraction, right? Mine was like a 3-layer fraction. And there's already a ton of layers inside of this 2-layer fraction, right? So this is a more concise version from the book, right? And I'm going to use the book's formulas as they give them today so that you practice with those. Plus, if we're just looking at a list of formulas, we don't have to use the intuitive approach like we were doing in the other slides, right? In the other slides, we were building up, just practicing the intuition of what was going on. We were either solving for A or solving for M, right? But this time, we know exactly we're solving for M, and we have this list of formulas. And that's the list they gave us. So we're going to take A equals 10,000 multiplied by R over N, which we said actually simplifies to 0.015. And then we'll divide that value, right? We'll divide that value by 1 plus R over N, which simplifies to 1.015, raised to the, double check its positive exponent, raised to the exponent 5, and then subtract 1. When I enter this into the calculator, I get the value 1,940 and 89 cents. You're always rounding to the nearest cent. Sometimes you round up, sometimes you round down. But this is our sinking fund. And you better bet and believe that we get to practice all the forms of the equations. I'm assuming. I mean, I think we do, but you have to assume it. The amount to be financed, so the amount to be financed on a new car is 9,500. So again, that's some future amount, right? That's like the, oh no, wait, sorry, I already messed myself up. That's the amount we want to finance. That's the purchase price, right? That's a P. P equals 9,500 because that's the amount we want to finance. The terms are a rate of 5% for 2 years, monthly payments, so N equals 12, right? And they're asking us for a monthly payment, right? Last time they asked us for M, and A was known. So we went with the sinking fund. This time, right? This time we have that P is known, right? And so this falls under the amortization because the form of that equation is M, which is the thing we're looking for, and then P times R over N as a numerator, and then 1 minus the quantity, 1 plus R over N raised to the negative NT. So 5 here falls under amortization, right? And I mostly just look at what variables are available, but there's also examples of when to use these, right? So definitely look through the examples, look through the variables, right? That sort of thing. So filling out our equation, then we have 9,500 times R over N, divide by 1 minus 1 plus R over N to the negative NT. NT, we didn't calculate it, would be 24. So to the negative 24. Right, just to make note. And then what we do is we put that into the calculator. And to the nearest cent, I get 416.78. That's a monthly payment, right? So it should be smaller than the amount we're trying to finance, which is the price of the car there. Okay, so we've gone through 4 actual problems, right? We're on number 6. Number 1 was that sheet that you should definitely print out for yourself and or copy entirely if you can't print it out, right? Just do it by hand. It may even get more solidified for you if you write it by hand. Okay, what is the monthly payment? Again, an M question. So I think you should just go ahead and collect information as you read it, right? So what is the monthly payment? M equals question mark. We are also told monthly, right? So 12 is N. For home costing 475,000 with a 10% down payment, which means we're only going to finance 90% of the 475,000. Keep saying that wrong. Right? Because it's this minus 10% of 475,000, which is just 90%, right? So they pay up front 10%, they're only going to finance 90%. I don't have an eraser on this one. It kind of drives me a little batty. But I need that space over there, so looks like that's as far as I can go back. Okay, let's keep reading. The balance, that's P for us, right, is financed for 30 years. So T equals 30. At a rate of 0.035 in decimal form, 3.5%. And other values that we use are like NT, right? So NT is 360. R over N doesn't simplify, so we'll just leave our list at this, right? Again, they're asking us for an M and they gave us a P. So this is the same as the last one, right? Amortization. So they want to know M and they gave us a P. Denominator 1 minus 1 plus R over N to the negative NT. Just plug it out, right? So I literally stuck the 0.90 times 475,000 in and multiplied times the R divided by N as the numerator and then I divide by 1 minus 1 plus rate, divide by n, raised to the negative 360, rate negative 360. Which gives a value of 191967 to the nearest cent. All right, number 7. What is the necessary amount of monthly payments to an account? So they're asking us for M again. What is the necessary amount of monthly payments? Such a weird way to say it. To an account paying 1.2% compounded monthly in order to have, that's a future value, in 8 1/3 years. So I'm going to represent T as an improper fraction. So 8 times 3 is 24, plus 1 is 25. So 25/3. Because we have to multiply n times t, right? Which will cancel in this form to be 4 times 25 or 100, right? So n times t is 100. And that's the only time we use t anyway. R over n will simplify nicely, right? R being 0.012 divided by 1/2 gives us 0.001, right? So 0.001. And then from there, we also can say that the 1 plus R over n is 1.001. Okay, so we've collected a bunch of stuff, right? When they ask for M and give us A, that was, right? So that was the form M equals A times R over N, divide by 1 plus R over N to the NT, take away 1, and then plug and chug, right? So we'll have 100,000 times R over N, which we cleaned up. And then we have 1 plus R over N raised to the exponent 100, take away 1. A lot of ones and zeros in that. Okay, so sticking that in the calculator, gives a value of 951.33. $951.33. Oh, I was trying to move the page up, but I have to close the annotator first. Okay, let's take a look at 8. If an apartment complex will need painting in 4.5 years. And the job will cost $115,000. What amount needs to be deposited? So how much needs to be deposited into an account now? So that's a present value. In order to have the necessary funds in the future, right? So that's an A value here. The account pays 2% semi-annually, which means that R over N cleans up to 0.01, and 1 plus R over N cleans up to 1.01, right? And then we have to figure out what they're asking us. They're asking us for P. They're giving us an A, right? So we have two formulas to solve for P. One of them has an M and one of them has an A, right? So this is a present value formula. And we'll use P equals A times 1 plus R over N to the negative NT. So again, this is written in the cleaned up form versus I was just doing A divide by when you have a positive one of these exponents, but this is the same action, right? Because a negative exponent just means that the quantity that it's touching is in the denominator, right? So two different versions of the same equation. I'm sticking with the books versions today so that you can practice them for the test and just use the books versions, right? Instead of the intuitive approach that we were using before. Okay, so let's fill this out. We have 115,000 times 1.01 raised to the negative, do we do NT? NT, which is 9. Now, be sure to use a negative exponent when the formula calls for a negative exponent. Otherwise, we won't get the right value, right? This gives me a value of 105, 149, and then to the nearest cent is 8 cents. So we need to deposit $105,149.08 into the account so that we have enough to paint the complex in 4.5 years. So not bad. We get like 10 grand for quote unquote free, or it seems like a 10 grand discount to us, right? Because we didn't have to pay it. We just had to put the money away until the paint job happened. So not bad. I approve. I don't mind it. Free 10 grand. Good. Number 9, Teal and Associates needs to borrow 65,000. So needs to borrow 65,000. That's generally like the purchase price, right? So let's try to collect our bits. I'm going to just try to stick to the side over here. So 65,000. The best loan they can find is one at 13%. That must be repaid monthly. So N equals 12 over the next 3.5 years. How much will the monthly payments be, right? So they're asking us for M. When they give us M, when we're looking for M, we have two formulas. One, A is known, the other P is known. We're looking for M and P is known. So this is amortization, right? Where we have M equal to P times R over N divided by 1 minus quantity 1 plus ratio R over N raised to the negative NT. Okay, so R over N doesn't clean up. N times T, that will be 42 again, right? We saw that number before, actually. Okay, so let's plug and chug. We have 65000 times 0.13 divided by 12. And then that's divided by 1 minus 1 plus 0.13 divided by 12 raised to the negative 42. When I put this into the calculator, I get the value 1934.54. So before we were just really practicing the calculator work, right? Now that we've gotten good at entering things into the calculator when they tell us which formula to use, now we're having to pick which formula to use and then enter it correctly into the calculator. So hopefully by now you've gotten good at the calculator work, because now we're just finding these answers all jumbled together, right? Which is definitely more of a challenge. But you can do it, right? Use your formula sheet, get your list of things that you have, and then see what they're asking you to find, right? So certain concrete company deposits, so a deposit, 2,000 at the end of each quarter. So they're putting in $2,000 regularly 4 times a year into an account paying 4% interest, compounded quarterly. What is the value of the account? So what's A at the end of 7.5 years, right? So if we look at our list, there's 2 formulas to solve for A, as long as we're not talking about compounding continuously, which we'll see in the very last question. But so we have 2 formulas to solve for A. In one, they give you M, and in one, they give you P. We need A, and we have M. So this is an ordinary annuity. And the formula for ordinary annuity is A equal to M times the quotient of the quantity 1 plus R over N raised to the NT, take away 1, divide by R over N. So that's our formula. R over N simplifies to 0.01, and 1 plus R over N simplifies to 1.01. So when we go to plug and chug, we have $2,000 for the regular payment, right? And then in the numerator, we have 1.01 raised to the, I didn't find NT, so let me put it up here. NT, 4 times 7.5. 4 times 7.5 is 30. And so we have an exponent of 30. Take away 1 from that quantity, and then divide by 0.01. Put that into your calculator, and I get back an amount for the ordinary annuity of 69 $1,569.78. So it's always, what do you have and what are they asking you to find, right? Those are generally my questions. Of course, on the list, there are examples. So like when it says lump sum, you go look for the one that talks about lump sum if you want, right? That sort of thing. Otherwise, I just like trying to make a list of stuff I have, a list of stuff I need. Let's go on to the next problem. Number 11. What is the future value? What is the future value? They just like flat out tell us the what to use there. I'm gonna guess you want us to find the future value. So what is the future value of an investment? So our deposit, our principal, right, of $112,000 for 5 years at 8% compounded monthly, right? When we look at the future value formula, again, they're asking us for A, they give us P, right? There's only 2 formulas where they ask us for A, and one has M, the other has P, right? So we use the one with P, which again, just to double check, is the future value formula. So A equals P times 1 plus R over N raised to the NT. That's like refreshing at this point, right? This is the original compounding future value using compounding interest formula that we used, right? It's like the one from 11.1. So 0.08 divided by 12. And then this is raised to the, we didn't do NT, but NT is 5 times 12. 12 times 5 is 60. I'm going to stick this into the calculator. I get 166,862.72. Okay, so we're about 2/3 done. Well, we're exactly 2/3 done. So just another 5 problems to go, right? But of course, the last problem is 2 problems. So we're almost there. We're getting there, right? We've used a lot of the formulas. We're still going to end up using that compounding continuously formula, and I feel like we might have used all the other ones then. So we really are just practicing identifying, or as the book words it, classifying, right? All right, so let's go to 12, right? Just have, you can even see on the pages, we're on page 4 of 5, so we're almost there. On number 12, then let's see what we have. Sebastopol movie theater will need in the future, right? So that's going to be an A value that they're giving us, a future amount. So in the future, they will need $120,000 in 3 years to replace the seats. What deposit should be made today? So what should our present amount be in our bank account, right? If we have an account that pays 9% compounded semi-annually, right? So that this is the scenario. They're asking for P. There's two equations that solve for P. One has M, one has A. We have the one with A. That's the present value. And I even said that kind of when I said what is the present amount that should be in the bank account right now in order to build it up to this amount, right? So present value. Then we have the formula that P equals A times 1 plus R over N to the negative NT. Does R over N simplify? No. Well, I mean, it could, right? Not terribly. So that would be 0.045, right? And then 1 plus R over N is just 1.045 then. And our last bit that we would need would be like the NT. NT is 6, right? 2 times 3 is 6. So that's our list of variables, right? And then from there, we can just plug and chug. We have 120,000. Sure you get your 4 zeros times 1.045 raised to the negative 6. Again, if we don't get that negative in there, we will suffer, right? Sticking this into the calculator gives me a value of 116,810 to the nearest cent, 42. So we're only going to get 4 grand by doing this, right? Almost even just 3 grand, but still that's a grand a year that we're earning that we don't have to end up paying out of our own pocket, right? So in order to have $120,000 to fix the seats, we're going to want to have this much in the account right now, right? So we should go deposit this amount. That way we can fix the seats in 3 years, right? So that was a present value. And let's clear that out. Number 13, last page. Woo woo. Number 13, a lottery. Oh, I like these ones. A lottery offers you a choice. I wish there was more color choices for me to write in. A lottery offers you a choice of $1 million per year. Yes, please. For 20 years, or a lump sum payment. What lump sum payment, we saw this word before, rounded to the nearest dollar, would equal the annual payments if the current interest rate is 1.1% compounded annually. So let's get our list of components over here. Okay, so they're giving us regular payments of $1 million per year, right? So M is 1 million, N is 1 because it's annually, T is 20. What else do we have? They want to know what lump sum payment that we should use right now, right? And so they have in the examples for present value of an annuity, as in selling off the proceeds from an insurance policy or winning the lottery. So just looking at our examples there, we know which one to choose. So they're saying then they're asking us for P, right? So because of this lump sum lottery buyout thing that's going on here. And we saw that lump sum voice before, and that's the present value of an ordinary annuity then, because of that lump sum. And so here we're going to have P equals M times 1 minus 1 plus r over n to the negative nt all over r over n. Okay, so that's the formula. We have n, we have t, we have m, right? That's all that we have here. We need r still from the list. That's the 1.1%, which is 0.011. And r over n, then if we just get our little extra bits together, since n is 1, it's just the same value as r. And then 1 plus r over n is 1.011. The other bit that we always need that I never seem to have space for is our nt, right? Which is 20, right? Because when n is 1, that just really simplifies everything. So thank you, examples with annual. Now we put in 1 million, so 6 zeros, times 1 minus parenthesis 1.011 raised to the negative 20. Make sure you get that negative exponent. Divide by 0.011. So first I just simplified off to the side, right? Then I go ahead, make sure all these zeros and ones are correct, and enter that into the calculator to get a value that if someone, if they're offering us the $1 million a year or a lump sum payment, then the lump sum payment that we would expect would be $17,865 and oh, sorry, I cut myself off early. $17,865,149, rounding to the nearest dollar. So to get your full 20 million, right, you would take this sum now and then go invest it, right? So that it would also give you the $20 million in the long run, right? These are, of course, cleaned up situations where we don't even talk about taxes. Yes, please. I would like some of that money, right? We could like buy C&M or something with that money. Let's see. Okay, let's look at the last few, right? We just have 3 questions left, but there are 4 questions there. Okay, so consider a 30-year fixed rate home loan. So this is going to be a home loan, but I'm not going to write anything down yet because there's always like twists, I think. With an interest rate of 3.75%. What is the total amount of interest, right? Because we're not picking formulas anymore. Now they're going to make us work for it. So even though I got excited that we were almost done, it actually got a little difficult. So let's look. Consider a 30-year fixed home loan. So I'm going to write down what I have, right? I've got a 30-year loan. I think that's P, so I'm going to call that P, right? That's the loan amount, principal, with an interest rate of they're asking us for interest paid. So if we look back at the idea that future amount is principal plus interest, then interest is future amount minus principal. So we first have to find the future amount. But it isn't A that we find here. Not yet, right? So we have to find A, but to find A, we have to find M, right? Because what we have here is P, R, and T, right? P, R, and T. That would give us the future amount if we were using future value, but that's not how home loans are done, right? So we have to look for what can we fill out when we have a P and R and a T, right? A P and R and a T only. Well, I mean, we have N as well. So we have to first actually find M, right? And then find A. So I can't erase. Let's see if I can back. Trying to back out of that. Okay, we do want A, but first we have to find M because we only have two equations that we could enter this input into, right? So so N will be 12 here, right? So that we can first find M and then find A and then find I. Okay, so that's the path for 14. And partly why we're using the formula we will and not future value, again, is because this is a home situation, right? And so when we have PRT, these home loans, we've been using amortization, right? That's the home loans. So the amortization formula with the variables that we have, right? P times R over N, divide by 1 minus 1 plus R over N raised to the negative NT, right? That looks gross, but that's supposed to be an R over N right there. So we have that stuff. And then we said N equals 12 because when you're paying off a home loan, you're paying it in monthly mortgage payments, right? So they really made us work for the information in 14, right? So from this, we could do R over N. That doesn't simplify. N times T, though, we'll need that. That's 360. Okay, so P 51550 times R divided by 12 all over 1 minus 1 plus rate divided by 12 raised to the negative 360. That's going to be how much we pay per month, right? So step 1, step 2, and step 3, right? These are the questions we're asking. So here we are in step 1, where we're finding the monthly payment. So the monthly payment, the mortgage payment, if you will, right, is going to be 2387.36 if you were actually paying the bank, but we have to carry this forward, right? So I'm going to put all the decimals down, all the decimal place values down. If we were answering the question here, we would stop at the 36 cents. But what I notice is the book, even if they make you round to enter something, they'll still leave it in the calculator and carry on the next calculation. And so we'll just leave that in the calculator. And I'm going to switch colors maybe for step 2, right? So step 2. Step 2 is in like, what's the future amount, right? Now we have an M, but we don't want to use that like ordinary annuity junk. We just want to think it out intuitively. We're going to pay this amount, and we're going to pay it 360 times, right? So if we pay 360 of these payments, right, leaving it alone in your calculator so that you don't mess it up, then we see that we're actually paying for the house, right, a total of 859,449.91. Okay, so that's our future amount, right? Just in that, like, we're going to make 360 payments of this amount. Finally, we can answer the question, what is the total amount of interest, right? So step 3, we'll take the amount we're actually paying and then we'll take away the amount of the house, right? The purchase price or the financing that we did, right? And that gives me a difference of 949.91. See, 343,941.99. That's finally the answer to 14. That the paid is 343,949.91 in money. Money, money, money. Okay. That one was hefty, right? 14 is hefty. There was a lot to think out. That it wasn't very straightforward. We had to work for it. We really had to work for it, right? And in the past, I was able to say, what's the question and what are they giving me, right? And this one I had to ask myself, what are they giving me? And what can I even do with that, right? So like looking at the input that they gave me, which was really just these 3 here, right? So I said, looking at the input that they gave me, which formulas can I even insert that into? And that left me with 2 choices, either present value, oh no, wait, either future value or that amortization. And considering it's a home loan, we went with the amortization, right? So that one I really had to use like the examples of how when you apply it. I first isolated the input and then asked myself, what do the two formulas that I have input for, what do they apply to? And only one of them applied to home loans, right? So yeah, that one took some work, because then after we got there, then we had to realize we make 360 of these payments. So in fact, it scales up to this amount. But then if you don't leave all the digits in your calculator, you're going to mess this step up anyway, right? And then step 3 was finally to like subtract the two and look at just the interest. So technically we looked at A equals P plus I, right? Using a home loan version of the amount. Okay, so let's clear that out, right? We've got 15 sitting here. Oops. So 15, it feels like, oh my gosh, it's gonna be another one of those. But they should have did 15 first, because 15 is step 1 of the last process, right? And it's just step 1. We do step 1 and we're out, right? We have a 30-year loan. We're going to finance $403,500 with an interest rate of 0.03875. So my point is, sometimes it pays to, if you get stuck on 14, for example, move on, because doing 15 actually was like, oh, that's the first step of the last thing, right? So 14 was hard. And then 15 is just like a third of that. So they're asking us what the monthly payment is, and they give us P, R, and T. This fits amortization, just like the last one that we did. Amortization. I always add an extra syllable. Amortization. Okay, so that is the formula: P times N over R divided by 1 minus 1 plus R over N raised to the negative NT. When we fill this formula out, right, we need N, which again is 12, because this is a mortgage monthly payment. So N equals 12. N times T, generally something we need, that's the 360. And plug and check, right? So 403,500 times 0.03875 divided by 12. And then our denominator, 1 minus 1 plus 0.03875 divided by 12 raised to the negative 360 in your exponent, right? When we crunch this out through the calculator, get a value of $1,897 and to the nearest cent, 41 cents. So that's our mortgage payment. And so that was step 1 of the last problem. Step 2 was then to multiply this by 360. And step 3 was to then subtract the original amount from this times 360 to find out what the interest we were being charged is, right? So yeah, definitely 14 was a doozy. 15 was simpler, just one step. And then 16 is a two-partner, right? So inflation, continuous compounding, A equals P times ERT, right? We're being told. In 1982, the inflation rate hit. So we have a rate of 16%. Suppose the average cost of a textbook in 1982 was $25. So the present amount of a textbook in 82 was $25. What was the expected cost in the year 2017? So T is 2017, take away, not 18, dang, they're not that old, 1982, to find that T has a value of 35. Is that all we need? P, R, and T? Okay, so A equals P times E to the RT, which is 25 times E to the 0.16 times 25. We just stick that in the calculator, right? And it spits out $6,760.66. That's A, right? That's just plug and chug. For B, I'm going to switch colors. If the average cost of a textbook in 2012 was actually $225, what is the actual inflation rate? Okay, so for B, they're giving us 2012 as the ending year, which means we only went 30 years. They also are telling us that the future amount in 30 years is 225. So if A equals P times ERT, then we have $225 equals $25 times E to the unknown rate for 30 years, right? If we divide both sides by 25, I get the value of 9, which equals E to the 30R, just switching order, because generally we put numerical coefficients in front of the variables. Now I have to take the log of both sides, right? So I'm going to take the natural log because that's how we get rid of E. That brings me to 30R. And then finally, if we solve for R, then R equals ln, oh, I put ln of E on that side. And I don't have an eraser, so all I can do is backtrack. Or I could write over it. I'm going to backtrack so that it's written correctly, if it lets me. Okay, that should have been a 9. Sorry, I was talking about ln E, getting rid of the E. And so I accidentally wrote it. So that gets us to this side. Right now, if we solve for R, then R equals ln of 9 divided by 30, right? I wrote that very largely, but when I stick that into the calculator, ln of 9 equal divide by 30, I get a 0.073, which is the percentage 7.3%, rounding to the nearest 10th of a percent. So hopefully you found this homework useful in being able to sift through the 2, 4, 6-ish formulas that we have, 6 to 8 formulas, 8 or 9, right? Depending on how you count them, formulas that we have. If you have any questions, by all means, please send me an email. Otherwise, that is it for section 11.7. Thank you.